Assalamualaikum and good morning. So today, my friend and I will explain to you briefly about thermal application in heat pump. I'm Muhammad Izzat Syahmi bin Muhammad AMIJAR. My metric number is 200940.
My name is ZIHNI bin ZAIDI. My matrix number is 200532.
So we will start our presentation with defining what is a heat pump.
So before we enter the deeper discussion about thermodynamics application in heat pump, so what is a heat pump? So a heat pump is a device that transfers heat from a colder area to a hotter area by using mechanical energy. Basically, heat pump moves thermal energy in the opposite direction of spontaneous heat transfer by absorbing heat from a cold space and releasing it to a warmer one. A heat pump uses external power to accomplish the work of transferring energy from the heat source to the heat sink. And heat pump is not a new technology, and it has been used around the world for decades. Refrigerators and air conditioners are both common examples of this technology. As most common design of a heat pump involve four main components, which is a condenser, an expansion valve, a evaporator, and a compressor, just like picture that given in this slide. And the heat transfer medium circulated through these components is called as refrigerant. So next slide, please. We move on to the next slide.
So how does it work? So as ZIHNI said before, a heat pump is an electrical device that extracts heat from one place and transfer it to another. Heat pumps transfer heat by circulating a substance called a refrigerant through a cycle of evaporation and condensation. A compressor pumps the refrigerant between two heat exchanger coils. In one coil, the refrigerant is evaporated at low pressure and absorbs heat from its surrounding. The refrigerant is then compressed en route to the other coil, where it condenses at high pressure. At this point, it releases the heat it absorbed earlier in the cycle. So, the heat pump cycle is fully reversible and heat pumps can provide year-round climate control for your home. So, it means that it can be used either heating mode and cooling mode. In heating mode, the outdoor coil is an evaporator, while the indoor is a condenser. The refrigerant flowing from evaporator carries the thermal energy from outside to indoors. Vapor temperature is augmented within the pump by compressing it. The indoor coil then transfers thermal energy included from the compression to the indoor air, which is then moved around the inside of the building by an air handler. And in cold weather, the outdoor unit of an air source heat pump needs to be intermittently defrost. This will cause the auxiliary or emergency heating elements located in the handler to be activated. At the same time, the frost on the outdoor coil will quickly be melted due to the warm refrigerant. The condenser or evaporator fan will not run during the frost mode. The indoor fan will continue to run during the frost cycle. In cooling mode, the cycle is similar, but the outdoor coil is now the condenser and the indoor coil is the evaporator. This is the familiar mode in which air conditioner operate. So we move on to the first law of thermodynamics. So what is the first law of thermodynamics? The first law of thermodynamics states that heat is a form of energy and thermodynamic processes are therefore subject to the principle of conservation of energy. This means that heat energy cannot be created or destroyed. So the formula for the first law of thermodynamics is U, which is change in internal energy, equal to Q, which is heat added to the system minus work done by the system. So on the diagram on your right, you can see that a heat pump for the first law of thermodynamics. QC, which is heat in, represent the thermal energy taken from the outside air. Which means that air will enter the heat pump. QH represent the thermal energy transferred to the inside of the house. So from inside, we transfer it to the outside. W represent the work needed to achieve this. TC is the temperature of the heat pump's working fluid. And TH is the final temperature of the heat pump's working fluid in vapor mode, and TC before this in liquid mode. The first law of thermodynamics is simply the principle of conservation of energy, which in the case of the heat pump states the increase in internal energy of a system is equal to the thermal energy added plus the work done on the system. So that's all for the first law of thermodynamics.
So for the second law of thermodynamics, basically the law states that heat transfer from a hot state to a cold state. So according to the second law of thermodynamics, heat cannot spontaneously flow from a colder location to a hotter area. The work is required to achieve this. An air conditioner requires work to cool a living space, moving heat from the cooler interior to the warmer outdoors. Similarly to a refrigerator, moves heat from inside the cold icebox to the warmer room temperature air of the kitchen. The operating principle of the ideal heat engine was described mathematically using Carnot cycle in 1824. An ideal refrigeration or a heat pump system can be thought of as an ideal heat engine that is operating in a reverse Carnot engine. Yeah, we use the reverse Carnot engine. So basically what is Carnot engine or Carnot cycle? The Carnot cycle is a reversible cycle, so the four processes that comprise it, two isothermal and two isentropic, can also be reversed. When a Carnot cycle runs reversely, it is called as a reverse Carnot cycle. A refrigerator or heat pump that acts on the reverse Carnot cycle is called as a Carnot refrigerator or Carnot heat pump respectively. In the first stage of this cycle, the refrigerant absorbs heat isothermally from a low temperature source in the amount of lower heat. Next, the refrigerant is isentropically compressed and its temperature rises to that the high temperature source. Then at this high temperature, the refrigerant rejects heat isothermally in the amount of higher heat. Also during this stage, the refrigerant changes from a saturated vapor to a saturated liquid in the condenser. Lastly, the refrigerant expands isentropically until its temperature falls to that the low temperature source. So that's all for the second law of thermodynamics. So by the end of this second law of thermodynamics, so that's all from us
Thank you.
about the thermodynamic application. So yeah, hope you enjoy and take note of the presentation that we just lectured you guys. That's all from us. Thank you.